Hello and welcome to my channel. Today I'd like to invite you to dive with me and touch a seafloor from the Ediacaran period. The Ediacaran period ends the Neoproterozoic era that began 1 billion years ago, and the period spanned from around 635 to roughly 540 million years ago. First, let's look at life development before the Ediacaran period to see how important the Ediacaran period was. In this video, I skip the theory of life beginning and I will begin with the oldest documented prokaryotes, 3.48 billion years ago, with possible 3.7 billion years ago. Then life forms that do not possess clear affiliation, maybe they were cynocytic organisms, colony or unicellular, or maybe even multicellular organisms. First eukaryote candidates around 1.65 billion years ago, and well-recognized eukaryotic forms, red and green algae, emerging near 1 billion years ago. The timeline highlights key evolutionary milestones in life development from unicellular to multicellular, but generally speaking, all in micro scale. Everything happened before 1 billion years ago. What was next? The barrier of 1 billion years was crossed, and around 890 million years ago, sponge-like structure was noticed. From the previous slide, we remember that algae evolved, and thanks to the whole oxy factory, around 850 million years ago, Neoproterozoic exudation event took place. At that time, Aspidella-like structures were noticed among fossils. The lasting Neoproterozoic oxidation event led to the most severe glaciation events in Earth's history, Snowball Earth, during the Cryogenian period. The name of the Cryogenian period comes from Greek word cryos, means cold. After the first cryogenian glaciation, Sturtian, Twitia disk dated for around 650 million years ago, marks the growth of subphotic benthic communities. After Marinoan glaciation in rocks dated around 620 to 605 million years ago, Aspidella appeared in fossils even with attached frond, and similar discovery dated around 613 to 597 million years ago. And here is important to tell what Aspidella was. The term Aspidella is used to the fossil in a form of holdfast of frondos. It was a disc shaped with concentric rings, a central raised bump surrounded by shallow depression with some creases and folds. Sometimes there is a trace of a connected stem or stalk. Aspidella fossils were really abundant. And now, at around 602 million years ago, Lancian biota mostly consist of macroalgae, and the reconstruction of Lancian biota shows amazingly rich forms of macroalgae. The fossils show that oxygen was present in Ediacaran oceans, at least locally, because complex organisms couldn't survive without it. Complex organisms like macroeukaryotes need oxygen to survive. Even oxygen-producing macroalgae still need oxygen to breathe. And finally, after Gaskier's glaciation around 575 million years ago, there was a bloom of a metazoa known as the Ediacaran biota. There are three major intervals of Ediacaran biota: Avalon, circa 575 to 560 million years ago, associated with slope and deep basin environment. White Sea interval around 560 to 550 million years ago, associated with the colonization of the marine shelf environment, and Nama from 550 to 539 million years ago, associated with organisms domination in shallow waters. By the way, the term Ediacaran is an adjective to describe the Ediacaran period origin. Ediacara specifies a geographical location, Ediacara Hills in Australia, because the biota from the location as Ediacara biota. Similarly, Shibantan biota or Charnwood forest assemblage. Avalon interval is represented by the first animals on Earth, exhibits taxa in a few broad morphologic types, the most recognizable Rangiomorpha and Arboreomorpha. Rangiomorpha encompasses sessile organisms that share a body plan comprising one or multiple fronds constructed of serially repeated leaf-like self-repeating branches. Some of Rangiomorpha lie on the floor as Fractofuscus, other as Charnia standard. And look at the size, true macro scale. Surface area to volume ratio suggests osmotrophy as the feeding strategy. Arboreomorpha has a central stalk with rows of primary branches and sometimes smaller cross branches. The Charniodiscus example illustrates how the branches worked. And today's sea pens are not true analogies. Charnwood forest assemblage revealed Aurora luminia attenboroughi fossils interpreted as a stem group Medusozoan. Medusozoan belongs to Nigeria, and Nigerian also include Anthozoa. A stem group includes extinct organisms that are more closely related to the crown group than any other group, but fall outside the crown because they branched off earlier. It represents evolutionary experimentation and gradual acquisition of defining features. Auroluminia is interpreted as a stem group Medusozoan, but had some Anthozoan features. Two incredible fossils, Hutia quadriformis and Mamsetia manuis, may be interpreted as a crown group Medusozoan and crown group Nigeria. A crown group includes all living members of a clade plus their last common ancestors and all of the ancestor descendants. Both fossils reflect Staurozoan-like peduncle and show the earliest fossilized muscular tissue. And Hutia and Mamsetia morphologically they are similar to modern Staurozoa. It means that split between Medusozoa and Anthozoa occurred in the Ediacaran period. Inaria carli from the White Sea interval has been interpreted as an actinian grade in faunal organism. Its morphology resembles simple actinians, sea anemone-like forms, and its presence suggests that stem group Anthozoans may already have existed by the late Ediacaran. If you remember from previous slides, a stem group is the set of extinct organisms that are more closely related to a particular living group than to any other, but do not yet possess all the defining features of the modern crown group. And the occurrence of Inaria carli in the White Sea interval, interpreted as an actinian grade organism, indicates that the evolutionary split between Anthozoa and Medusozoa had already begun by the Ediacaran period. White sea interval introduced Dickinsoniomorpha. Dickinsoniomorpha are defined as a serially repetitive organism with anterior-posterior differentiation. Two examples, Dickinsonia costata and Georgia wagoneri. Discovery of trace fossils are interpreted as evidence of feeding and movement. Further research suggested the organism consumed the underlying microbial mud, absorbing the digested material through its ventral surface externally. The Kinsonia morpha is interpreted as proarticulata, precursor of the segmented body. True segmentation is connected to Spriginia flandersi. Its segmented body hints at early arthropod-like organization. Icaria oruta shows direct movement, and Uncus jaxi, another worm-like organism, likely nematoda grade. Together, these organisms demonstrate that Actisozoa diversification was underway in the Ediacaran. Kimberella quadrata, a large soft-bodied organism interpreted as a stem mollusk. Its scratch marks and feeding traces indicate radula-like structure and active grazing and, of course, movement. Kimberella is one of the strongest pieces of evidence that Laphotocorozoans also existed in the Ediacaran, showing complex behavior and organ systems. These groups also showed that key protostomy lineages, demonstrating that the bilateral diversification began in the Ediacaran. Suspension feeding is a key ecological strategy in the modern ocean. Arkarua has been interpreted as the earliest known echinoderm, but this phylogenetic position is debated. But if Arkarua was an echinoderm, present-day starfish belongs to that group, and starfish represent deuterostomes at the early stage of development. We humans belong to Chordata, that is also a member of deuterostomes. There is also a suggestion that the triradial taxon Tribachidium was a benthic suspension feeder. Tribachidium could also have shown some degree of movement. Ernietomorphs from Nama interval are best interpreted as passive suspension feeder that use their modular tabular bodies to manipulate water flow and capture particles. Ernietomorphs are defined as serially repetitive organisms constructed entirely of tabular units connected side by side through linear system arranged into frond sag-like or canoe-like or even fan-shaped array representing bending recliners, and some show triradial symmetry around a single growth axis. Finally, Nama interval brought biomineralization with extraordinary form of Namacalatus, sessile bending skeletal organism with a flared opening. We can see the amazing structure of the exoskeleton of Carumbella werneri or Costabus bibendi, and the most famous Claudinia with discovered guts allowed researchers to qualify this taxon to palicid. Tube worms represented annelids group. The boundary between the Ediacaran and Cambrian periods is marked by a fundamental shift in how organisms interacted with the seafloor. Ediacaran animals produce relatively simple surface-level trace, essentially 2D exploration on the sediment. In contrast, early Cambrian organisms generated 3D exploration through vertically structured bioturbation and ecological hallmark of Phanerozoic life. The Nama interval, particularly the Shibantan assemblage, provides an important new perspective on the end of the Ediacaran. The discovery of Treptichnus steptosus, a vertically tiered burrow system in terminal Ediacaran strata, suggests a possible ecological bridge between the simplicity of Ediacaran mud ground communities and the dynamic, fully tiered ecosystems of the Cambrian. I've shown you only a selection of the known Ediacaran organisms. Many more species have been described. Together, they formed the first truly diverse macroscopic communities in the Earth's history, representing an unprecedented expansion of body plans and ecological strategies. Gliding over the Ediacaran seafloor from about 575 to 540 million years ago offers a sense of what that ancient world looked like and how it transformed through time. Avalon assemblage communities were dominated by erect sessile and low-lying sessile frondose organisms. These organisms were osmotrophic and entirely soft-bodied. The wide sea interval marks a major milestone in Ediacaran life, the appearance of motility. Feeding behaviors diversified, including external digestion, internal digestion, and a more complex form of suspension feeding. All known organisms remained soft-bodied, but their ecological strategies expanded dramatically. The Nama assemblage represents the true wind of change. Here, the first evidence of biomineralization appears, allowing organisms to build exoskeleton. This innovation fundamentally transformed marine ecosystems and foreshadowed the Cambrian explosion. Crucially, the Nama interval also shown the emergence of 3D exploration of the sediment. Despite the alien appearance, many Ediacaran forms may have shared biological or ecological traits with modern animals. Some were almost certainly early representatives of bilaterans and Nigerians. And once again, I'd like to show you the position of chordata. And we humans belongs to chordata, and chordata is a part of deuterostomes. And first echinodermata, first deuterostomes were noticed in the Ediacaran period. I titled my video Ediacaran Gardens, but I concentrated mostly on animals. But remember the Lancian biota, there were many of microalgae, and the most famous Flabelophyton is known from assemblage through the whole Ediacaran period. Also, sponges were noticed and microbial mats. The Ediacaran period represented true macroscale multicellular Precambrian life, with my favorite one, Dickinsonia. Thank you for watching this video. If you found it informative, please give it a thumb up and consider subscribing. With geo greetings. See you in the next video.